Hello, my name is Dr. Shabarinath, Assistant Professor in the Department of EC from VJYOTHI Institute of Engineering and Technology. So, welcome back to the lecture series on computer organization. So, today I am going to discuss about the important topic called the addressing mode. Okay, so before proceeding to the addressing mode, as usual, let us start with the basics. So, every computer has an every computer has an instruction set. So every instruction is defined based on the instruction format. So for example, let me take this instruction format for a computer is given by, so it has various fields. So it has a one field called opcode. So opcode is nothing but, opcode is nothing but a code which defines the operation. So operation to be performed by this instruction. So a set of bits used to represent the operation, right? Now this operation must be performed on the data, right? So every computation like addition, subtraction, loading data, storing data to the memory, loading data from the memory, all these operations must be performed on some data. So where the data reside, the data may reside either in the memory or registers, right? Now in order to represent that data related information, so basically we represent that with the help of an address, right? So with the we represent that information about the data. So in this case data is also called an operand, you know that. So that information of the data is represented with the help of address, right? So this address is may represent either a memory address, or a register address, right? So let me explain what is memory address and what is register address, right? Now first of all, what is an memory? So for example, if we have a memory like this, suppose I have memory has these things. So memory has a address lines, right? So memory has address lines. So memory has a data lines, you know this. Memory has data lines. Similarly, memory has control lines. So the two important controls lines are read and write, right? So this is a write, for example, and we have a read. So this is the memory. For example, if I have a 4 address lines and 8 data lines, how this memory is look like 4 address lines we have. So this memory has starting address from 0000. This is the address, and each location is storing a 8-bit data, right? So each location can able to store an 8-bit data. Like that, it has total 0001. So again it can store 8-bit data. So like that it can has total 16 memory locations. So total, again it can store 8-bit data. So it has total 16 memory locations. Means what? So this memory can be represented like this, like 2 power 4 by 8. What do you mean by this? So 2 power 4 is nothing but 4 address lines, 8 data lines. So total 4 address lines means total 2 power 16, total 16 locations. 2 power 4 is nothing but 16 locations, and each location it can store the 8-bit data. Now in this field, suppose if we want to use this memory for our computing in our with our computing system, in our computer organization, I need to preserve 4 address lines here. That is a meaning. So here I need to give the 4-bit address, right? So that is the meaning of memory, intuition behind the memory address, right? So what is a register address? So register address is nothing but it depends upon the number of registers. So in a computer, inside the organization of a CPU, we have a number of registers. So generally we call the register bank. Like we can have, suppose we have a 16 registers, right? Suppose we have a 16 registers. So what we give is like for starting from R0 to R15, like R0, R1, R2, R15. So what we give? So to give you, my intention is to give unique code for the each register. So since we have total number of 16 register, I use a 4-bit code. Like 0000 I give for R0, 0001 I give for R1, like that 1111 I give for R2. So this is the meaning of register address. So register address, the number of bits. So in this case I allocate 4 bits. So it depends upon the number of registers, so allocate number. So this is the intuition behind the address, right? So this is very important to understand what is address. Similarly, another important thing, information we give in the instruction is nothing but the addressing mode. Okay. So what is an addressing mode? So this addressing mode will dictate the addressing mode will be will dictate the rule for identifying the data for this particular instruction where the data is located, right? So the data may locate in the memory, the data may be located in the registers, right? So this addressing mode will define a rule, right? So let us go to the formal for identifying this location of the data, right? So let us go to the formal definition of this addressing mode and let us try to understand. So once we get into this, let us try to understand. So what we are trying to understand is, in an instruction we have, every instruction is dictated by opcode. Instruction is nothing but a binary code. It represents a opcode, address and addressing mode. Now we try to understand what is an address. Similarly, we try to understand what is meant by addressing mode, right? Now let us see this, what is addressing mode. So before proceeding with the thing, let us see the formal definitions of this. So what does addressing mode specify? Addressing mode specifies a rule for interpreting or modifying the address field of an instruction before the operand is actually referenced. Okay. Now what is the meaning of this? What is the meaning of this? So the addressing mode specifies a rule for interpreting or modifying the address field of an instruction, right? So before the operand is actually referenced. So it defines the rule, right? So addressing mode will specify the rule for actually referring to the operand. That operand may be located in the either register or in maybe in the memory. Now this based on this addressing mode will actually identify where actually that is located. So this addressing mode will define that rule, right? So finally, the effective address. So another important terminology you have to understand in this case is the effective address. So what is effective address? Effective address is nothing but actual address of an operand. So actual address of an operand. So this effective address is identified by the rule defined by this addressing mode. So that is what we try to do. So effective address is the actual address, right? Actual address of an operand. Now this actual address is identified based on the rule defined by the addressing mode, right? So let us try to see what is this addressing mode and the effective address. Let us try to understand with the help of an example. Okay. Now okay, let us come to this advantage later. Now let us see this example in this case. So this is one of the Morris Mano book example, as you know this, right? So let us take this memory organization. In this memory organization, the address number, so we have an instruction in the address number 200 and the 201. So these two address locations, so the address number 200, the address number 201 is storing our instruction, right? So what is the instruction here? Just now I shown that instruction is representing what? Instruction is representing the opcode. Few bits of the instruction is representing the opcode, few bits are representing the address, and few bits are representing the addressing mode. So in this case, I am storing this entire instruction in the two memory locations. That is the first thing you have to understand. So two memory locations. So what are those memory locations? So we are storing in the memory location number 200 and memory location number 201. So in this case, the opcode is nothing but load to AC. So this load to AC is nothing but opcode. Similarly, we have few bits reserved for mode. So mode is nothing but the addressing mode, right? Similarly, in the second memory location, we are storing the address. This is what the address, right? Address 500 we are storing. Now let us see, this is what the scenario. So first let us try to understand the operation of load to accumulator. What is meant by load to accumulator? Load to accumulator is nothing but load the value. After executing this instruction, what CPU will do? CPU will load some value to the accumulator. That value, where that value is present, that value may be present depending upon the addressing mode and the address. We need to identify that. That is what the intention now. Now load the data to the accumulator. That data may be present in the memory or the registers. So that depend upon the how we identify that where the data is located. So that depend upon the addressing mode and the address, right? That is our task now. Now in this computer organization, let us see this. So once your CPU is having this location number 200, so this is the first instruction. So your PC program counter, so program counter always points to the instruction starting address of the instruction in the initially, then we keep on incrementing the program counter, as you know, right? During the instruction cycle, during the fetch phase of the instruction cycle, we actually increment the program, as I told that we increment the program counters to point to the next instruction. Similarly, in this computer we have one register called R1, which is having the address 400. Similarly, we have one index register. So this is another index register. So the R1 is here the general purpose register. XR is nothing but the index register, which is storing the 100. Now finally the accumulator. You know that this accumulator is a register. Now this is the scenario. So using this scenario, I am trying to explain the various addressing modes which are very important. Okay. Now addressing mode will define a rule, right? Now let us try to understand in this scenario what is the number of what is the addressing mode. Let us try to understand with respect to this scenario. Okay. So first addressing mode, I'm talking about the direct addressing mode. So in direct addressing mode, the rule, what is the rule? The rule is nothing but this 500 is nothing but direct address of the operand. Right? So 500 is nothing but the direct address of an operand. So what is the 500 here? So you can observe here in this memory location, this is a 500, right? So in this 500, there is a data called 800. Now what happens after executing this instruction? The value present in the address number 500 will be loaded to the accumulator. So 800 will be loaded to the accumulator after executing this instruction. So here the important point is, what does this direct addressing mode is specifying? It is defining a rule. What is the rule? The address present in the instruction, it's a direct address. So where the operand is actually located. So that is the meaning. So in this case, the effective address, as I told, it's an actual address. This effective address is nothing but in this case, it's a 500. Right? It's a 500. The value loaded to the accumulator after executing this instruction, the value loaded to the accumulator is 800. Right? That is the meaning. You have to understand. Right? Okay. Similarly, next, immediate addressing mode. So in immediate addressing mode, so this 500 is interpreted as the data. It is not an address. So what does immediate addressing mode specify? Whatever the value, it's immediately available in the instruction itself. So 500 is interpreted as a data. Now after executing this instruction, the value 500 will be loaded to the accumulator. This is the meaning of immediate. That is a rule for immediate addressing mode. That is dictated by the immediate addressing mode. Now what is the effective address in this case? Effective address is nothing but the address where this value is stored. That is nothing but the 201. So in this case, the effective address is nothing but the 201. Okay. So this is the second addressing mode. Similarly, indirect addressing mode. So in this indirect addressing mode, the rule, what is the rule here is, so the value, the address present in the instruction, this is the address where actual address of the operand is stored. It's like that. So 500. So we have in the 500. So 500 where actual address is stored. So 800 is actually the effective address here. So this is the 800. So 800 is the address. So what is the rule here? In the indirect addressing mode, we are storing the address. So that address is nothing but actually it's like if you compare with the high level language, it's nothing but a pointer to a pointer, right? It's a double pointer. So where we have a 500, so 500 is actually the address where actual address is stored, right? So here 800 is the, so in this case 300 will be loaded to the accumulator and 800 will be the effective address. Right? So this indirect addressing mode requires one more extra memory access, right? For fetching the data. So that is the thing, indirect addressing mode. So the next addressing mode is the relative addressing mode. So what is meant by relative addressing mode? Listen here. So in this case, the rule, what it defines, so 500 is the value stored in the memory. So as you know that, so whenever this instruction being processed by the CPU, you know that the instruction, how it is processed, instruction is processed for every instruction, your CPU undergoes the instruction cycle, as I told in the first unit, right? In the instruction cycle, there are many substeps. What are the substeps? Fetching the instruction, it requires certain micro operation. After that, decoding the instruction. After that, finding the effective address. After that, executing the instruction, right or not? So while processing the instruction 1, your PC will be pointing to the, during the fetch phase, what we do, we increment the PC such that your PC will be pointing to the 202. So in this case, the relative meaning is, so we need to add the address given in the instruction with the PC value. So PC value in this case is the next instruction address, that is 202, to form the new address 500 plus 202. So in this case, what we do, 500 plus 202, we get the value as 702. Now in this case, 702 will be the effective address where the actual operand is stored. So this kind of addressing mode is used in the jump kind of branching instructions, where we use this kind of addressing mode. So but here the rule, you need to understand the rule here. The rule is that you just add the address with the address given in the instruction with the contents of the PC to form the new address. Now that new address will become the, so these two contents are added. So to form the new address, the two new address is nothing but the 702. So in the 702, you fetch the data and put into the accumulator, right? So 325 is put into the accumulator and the effective address will be 702. That is a rule of relative addressing mode. Okay. Next comes the index addressing mode. So in this index addressing mode, what the rule specifies is, we have an index register specified in the CPU organization. So we take the value of the index register and add with the contents of the address given in the instruction. So in this case, index register has a value of 100 as defined in our scenario, is added with the 500 to form the 600. So that in this case, the effective address is nothing but, so this value both added, we get a 600. So 600 will be the effective address. So in the 600 we have a 900. So 900 will be fetched and kept to the accumulator. That is a rule for index addressing mode. What is the rule here? The address present in the instruction must be added with the contents of the index register, right? In our case, the index register is nothing but the XR. Similarly, register indirect addressing mode. So in case of register, this is the register addressing mode. So in case of register addressing mode, right, the value present in the register. So in this case, we assume that the value present in the register R1, right? So the value present in the register R1 will be, this is the value, this is the actual value. So here we nowhere concerned with this address, we don't require any address, right? So we, in register addressing mode, the value present in the register will be loaded to the accumulator. That is a rule. So generally we have a number of registers, so we define certain register. So this value of the register must be moved to the, so in this case we are loading the value. So we are loading the contents of R1 to the register A1. So 400 will be loaded to the accumulator. In this case, there is no effective address since we are not referring to any memory location. So we don't have any effective address. So that is the meaning of register addressing mode. That is a rule, right? Similarly, register indirect addressing mode. So in this register indirect addressing mode, register is actually holding the address, right? So in this case, the register is actually holding the 400. So this 400 is nothing but the address. There is no concern with this address, right? So 400 is the address. This 400 is nothing but the effective address where the actual operand is stored. So that is a rule here. So we use one register as a pointer, right? It's like we use one register as a pointer, like here the register R1 acting as a pointer for holding the address. That is the actual address where the operand is stored. So 700 is loaded in the accumulator. That is the rule here. So similarly, auto increment. So auto increment is similar to the register indirect. So but here there is a one difference. So what happens? The contents present in the 400 is pointing, it's a address. So again here nowhere concerned with 500, we are not using this address. So that value present in the 400 is acting as a pointer. So this value is loaded. The value present in the 400, 700 is loaded. So after loading this value, one more thing happens, the value of R1 will be incremented. R1 become R1 plus 1. So R1 will become 401. So this is the two things happens. Generally in case of C language, what we use, we need to always, while processing arrays, after processing one element of the array, we need to increment the pointer. So it's like that. So auto increment is after it's both operations are integrated. We fetch the data from that respective location as well as we increment the pointer. That is the meaning here, right? Similarly, auto decrement. So please try to understand here. Previous case what we did in auto increment, first we fetch the data from the address, then we incremented the pointer. Now in this case the rule is that first we need to decrement the pointer, right? So first we need to decrement the pointer from 400 minus 1 will become 399. So from this 399 we need to fetch the data. So here the 450 will be fetched, 4 will be available in the accumulator. So here the effective address is 399. So that is a difference. Remember here previous case first we fetch the data then increment the pointer. In this case first we decrement the pointer then we fetch the data, right? So okay, this is the summary, right? So this is the summary. You can see here like so this is the effective address which we calculated. What is the effective address? Effective address is actually the address of an operand. How we estimate the effective address? Based on the rule defined by this addressing mode, right? So rule defined by the addressing mode, we estimate this effective address, right? Finally, this is in this effective address. So we have used the load instruction. So what happens? The value present in this effective address will be, that value will be loaded to the accumulator. So what values are loaded to the accumulator? These are the values as dictated, right? Now this is what the addressing mode. So addressing mode, so why we have this many addressing modes? So this many addressing modes are provided in every computer organization, right? So why we have this many addressing mode is to give the programming versatility to the user, right? So all these high level concepts like pointers to a memory, counters for loop control, right, indexing of data, program relocation, right, these are the various things we can implement in the high level language based on these concepts. Based on this various addressing mode we can implement all these concepts in the high level language, right? So that is the advantage we get, right? So to give the programming versatility to the user of the CPU, we have this many number of addressing modes. So also another advantage is to reduce the number of bits in the addressing field of the instruction. So this is another advantage, right? So suppose I need to, for example, without defining the rule, in this case what I need to include, I need to for example take this in this relative addressing mode, I need to include 202 plus 500. So two addresses I need to include. So instead of that, what we can do, we can reduce the, so by defining a rule we are trying to reduce the number of bits of an instruction, right? So here the instruction we are, so the total instruction length, whatever the instruction length I told, right? So this instruction total number of bits can be reduced, right? So this is the understanding about the addressing mode. Okay, now just I'll conclude this topic like okay, now see here, let me relate this addressing mode with the thing. So what is the thing what I'm telling? So first so we have I have started this with the concept of, I have started with this with the concept of instruction. uh, I've started with the concept of an instruction. So what is a computer instruction? Computer instruction is nothing but a binary code, right? So computer instruction is nothing but a binary code. I'm concluding this topic. So binary code, right? So this binary code will conveys various informations like okay, opcode, which is required to perform the operand, right? Operation, what operation it needs to perform. So that operation needs to perform on the data. That information I give it as addressing mode, address, right? So this address maybe belongs to register or memory. Now this address is not the final address, right? So based on the rule defined by the addressing mode, we need to find the effective address, right? So addressing mode, so these three information is given in the binary code, right? Now how your computer, again I'm relating with this, how your computer process this binary code. I told that your computer process this binary code by set of what, by sequence of micro operations, right? By sequence of micro operations, you know this, right? Sequence of micro operations. So what are the sequence of micro operations for processing this binary code? So it's divided into subphases, right? So what are the subphases? So we have a fetch phase, right? Fetch phase, what happens? So it performs certain micro operations to fetch this instruction located in the memory, fetch to the instruction register, right? That's what happens. Then decode. In this, your computer tries to give certain control signals to understand this instruction, right? Then it will find the effective address, right? How it will find the effective address? What is this finding the effective address, Andy? Now finding the effective address based on the addressing mode. So addressing, after decoding, your CPU will understand what is the addressing mode, right? So what addressing mode is there for this instruction, it will understand that respective addressing mode. After understanding the respective addressing mode, it knows the rule. So based on the respective addressing mode, it knows the rule of how to find the effective address. So based on that rule dictated by the addressing mode, it will find the effective address. So after finding the effective address, then it fetches the operand, right? It has an operand with it, it has a data with it. Now it knows what to do with the data, then it will execute this instruction, right? So this is what the relation, this is what you need to understand, the role of addressing mode in finding the effective address in this. So this entire thing, you know, right? To process one instruction, this is called an instruction cycle, right? Yeah. So this, here comes the conclusion of this, right? So in this video lecture, we try to understand the importance of addressing mode, and we related the addressing mode with the with one of the subphases of the instruction cycle, right? Thank you very much.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.